Okay. Today I'd like to explain the last tutorial material of basic math before midterm exam. That I want to explain about matrix. But I'm certain that you have been explained in the class by your lecturer, but so in this chance I'd like to just explain about the answer of last year midterm exam. So I'd like to jump into the question 5. Okay, we could read. Ivana and Diana love buying typical t-shirt and dolls from places they visited. When they traveled together to Sapporo, Japan, Ivana spent 16,000 yen to buy 3 t-shirts and 2 dolls. Okay, so you know that from these things, firstly, we should denote t-shirt into T is t-shirt and doll is D. And then we know that if I spend 16,000 yen to buy 3 t-shirts and 2 dolls. And then she just spent 9,000 yen to buy 2 t-shirts and 1 doll. So 2 t-shirts and 1 doll. Basically, this kind of things, it just linear equation, and you can solve by using the normal way. But in this case, because we learn about matrix, we have to solve this problem with matrix. So the first question express Ivana's and Diana's spending while in Sapporo in an equation system, then convert the two equations into matrix form. So the form of equation is like this, but how about the matrix form? Okay, I'm certain that you have learned this in the class. So the matrix form from this kind of equations is 3, 2, 2, 1. It's from 3, 2, 2, 1, 3, 2, 2, 1 times T and D equal to 16,000 and 9,000. So if you solve this kind of multiplication in matrix form, you can see that it's same as this one. So like 3t plus 2d equal to 16,000 and 2t and plus d equal to 9,000. Okay, so it's same. Yeah, but it just convert from the normal equation into matrix form. So it's the first equation. And how about the second one? Check the non-singularity condition of the equation system, then interpret the result. So the matrix is called singularity if the determinant of matrix is 0. So for example, if this one is A, this one is X, and this one is B, so A is called by singularity if the determinant of A is 0. So we can try to solve the determinant of A. So you know that the determinant of A is 3 times 1 minus 2 times 2. So 3 minus 4, which is minus 1. So we know that the matrix A is non-singular. So the system of equation has unique solution. So if the determinant A is not 0, so it's non-singular, yeah, and the system of equation has unique solution. Okay, so this is the for question B, and then for the question C, yeah, write the minor, cofactor, and adjoint matrix of the coefficient matrix in the equation system. So what is the minor? The minor, we can find the minor matrix. We can find the minor matrix by eliminating the first the column and the row. How to do this? For example, if A is 3, 2, 2, 1, yeah. So this one is A11. This one is A12. 1, 2 is row 1 and column 2. This one is 2, 1, yeah, row 2 and column 1. This one is A22. So the minor 1, 1, yeah, minor 1, 1 is we should eliminate the column and row. So we, for M11, it's like we should eliminate row and column, because 1, 1 is row 1 and column 1, so we should eliminate the first column and the first row, yeah. So the remaining is 1. So minor 1, 1 is 1. Okay, and then how about the minor 1, 2, yeah, 3, 2, 2, 1. Okay, minor 1, 2 is minor 1, 2 is, firstly we have to eliminate the first row, yeah, the first row and the second column, yeah. So the remaining is 2. But we have to, you have to know that because this one is 1, 2 and 1 plus 2 is 3, yeah, which is an even number, yeah. The odd number, yeah, this one is odd number. So if row plus column is odd number, yeah, we have to put minus before the minor, yeah. How about M21? M21, so we have to eliminate the second row and first column, so the remaining is 2. And we know that 2 plus 1 is 3, so it's the odd number, so we have to add minus before the minor. And finally, for the minor 2, 2, yeah, we can eliminate the second row and second column, so the remaining is 3. And because 2 plus 2 is 4n, which is the even number. So we don't have to add minus before the minor. So this thing is minor. And then how about the cofactor? Cofactor is the combination between minor, but we don't have to put minus in cofactor. So the cofactor is 1, 2, 2, 3. Yeah. And adjoint is the combination of minor, but we should write the exact number, which is if in minor there is minus, so in adjoint we have to write minus. So adjoint is 1, minus 2, minus 2, and 3. Okay, this one is adjoint A. And then finally we have to solve T and D. T and D. Yeah. We have to use firstly matrix inversion rule, and secondly Cramer's rule. Yeah. Secondly is Cramer's rules. So for the matrix inversion rule, yeah, as I have said, as I have written before, these things. So AX equal to B. So we have to find X because we have to find T and D. So X is A inverse times B. Yeah, A inverse times B. Okay. So how to find A inverse? So we know that A inverse is one of the determinant of A times adjoint A. We know adjoint A is this, so it's easy basically. 1 over the determinant of A is minus 1. You know that before in here, minus 1. So adjoint A is 1 minus 2 minus 2, 3. Yeah. So A inverse is minus 1, 2, 2, and minus 3. Okay, this one is A inverse. And we know that X is A inverse times B. A inverse is minus 1, 2, 2, minus 3. So B is, how much B? B is 16,000 and 9,000. So it's times 16,000 and 9,000. So we know that because this one is 2 times 2, this one is 2 times 1. So the result should be 2 times 1. So minus 1 times 16,000 minus 16,000 plus 2 times 9,000, so 18,000. And this one is 32,000 minus. So the answer is 2,015,000. So we know that, yeah, we know that no, not 15,000. So it's 5,000. So we know that T is 2000 and D is 5000. Okay, it's easy. This one is matrix inversion rule, and the second way to solve this problem is to use by using Cramer's rule. So Cramer's rule. Okay, so how to solve by using Cramer's rule? Cramer's rule is like this. So I think we should copy and paste this kind of things. Sorry. Okay, copy and paste here. Okay. Firstly, to find T, which is this one, is we have to find the determinant of AT, yeah, over the determinant of A, yeah, and to find D is the determinant of AD over the determinant of A. So what is the determinant of AT? The determinant of AT, yeah, we should because T is in here, yeah, we should change 3 and 2 by this one, yeah, by the product. So 80 is 16,000, 9,000, 2, 1. And the determinant of A, we know that this is the minus 1. So this one is 16,000 minus 18,000 over minus 1. So the result is 2,000. Yeah. And then AD, yeah, we have to change 2 and 1 by this one. So 3, 2, 16,000, 9,000. And we know that the determinant of A is minus 1. So 27,000 minus 32,000 over minus 1. So this one is 5,000. So we know that T is 2,000 and D is 5,000. Yeah. Okay, so this is the what's that? The answer of question 5, and good luck for your exam. And I think you can, if you have any question, you can ask in WhatsApp group. Yeah. Okay, thank you everybody.